Vilbron the Science Bomb.
Vilbron the Science Bomb.
All right, welcome to WSQ number 11. Today we are going to talk about the changes of states of matter, the changes of phases in matter. And specifically, we're going to look at what happens to a substance during changes between solids and liquids, what happens during changes between liquids and a gas, and what happens between changes between a solid and a gas. And so we're going to learn about some different state changes, 5 of them in fact, that will help us better understand how substances transfer from a solid to a liquid to a gas and vice versa. The first one we're going to discuss is melting. Melting is the change in state from a solid to a liquid. Okay, the big key right here is we're going from a solid state, tightly packed. As we remember from WSQ number 10, the particles are closely attracted to one another, and those particles are just basically vibrating. Well, as melting happens, the particles in the solid vibrate faster and faster and faster to the point that they actually break free from their fixed position and become a liquid. That's what happens in melting. So you take solid silver that, as it's heated, there comes to a point eventually, which we call the melting point, right? At which that solid silver melts and becomes liquid silver. It's freed. Okay, so they're broken free from their fixed position, and now they're actually able to move around one another. So melting solid to a liquid, and the point at which this happens is known as the melting point. The second type is freezing. Freezing is the change from a liquid to a solid, okay, as we know. And in this case, we have the opposite result. So you have particles that go slower and slower and slower to the point they move so slowly that they actually take a fixed position. So in this example, you start with something like liquid water, and as you come to that place, as you come to that point, okay, you'll come to a point known as the freezing point. All right, in the case of liquid water, we know that's 0 degrees Celsius or 32 degrees Fahrenheit. Well, you get a point at which that's starting to move so slowly they can't continue to move, and they actually take on a fixed position. Okay, and that fixed position, now they've changed from the state of a liquid to a solid. Okay, so it's either the increasing of particles we saw in melting or the decrease in particle speed, which is called freezing. You then have vaporization. Vaporization is a change from a liquid to a gas. Okay, and vaporization is when the particles get enough energy, they're gaining it, so they're getting faster, that they can actually break to the point where they're no longer confined like a liquid. They can move independently. They have indifferent shape and an indefinite volume. And so in the case here, we see 2 different types. You can have evaporation. Evaporation is a type of vaporization, and the easiest way to think about evaporation, this is slow vaporization. Okay, it's slow, it's happening slowly over an amount of time. Notice that you have the water vapor only vaporizing off of the surface and changing from a liquid to a gas. In boiling, the second type, this is a fast vaporization. So what happens here is as the heat's applied, the water molecules, okay, actually form bubbles, okay, that come to the surface, and as they pop, the gas is released. So it's not just at the surface as we saw in evaporation, it's throughout the entire liquid. And so boiling, this happens, vaporization happens at the surface and within the liquid, which causes a much faster change from a liquid to a gas. And we know that the temperature at which vaporization happens, okay, is called the boiling point. So the boiling point is the time at which a liquid actually boils or begins to vaporize both inside and at the surface. And we know the boiling point of water is 100 degrees Celsius, okay, or 212 degrees Fahrenheit. So that's vaporization. So we have melting, That's a change of a solid to a liquid. We have freezing, a liquid to a solid. We have boiling or vaporization, a liquid to a gas. Then you have condensation. Condensation is the change in state from a gas to a liquid. So similar to what we saw in the other forms. Condensation occurs when you have less and less energy. So as a gas is moving around, as it starts to cool, it removes energy, less and less thermal energy. It starts to come together and it can condense. Okay, usually on, we see this a lot in the morning with dew and things like that. And it actually forms a liquid. So the particles are loose enough that the thermal energy, right? So they lose enough of this thermal energy, okay, that they can form a liquid. And that's what happens in condensation. And so you'll see condensation oftentimes will happen as you may have a hot cup or something like that. And as that hot cup, as it cools, as the glass, which is cooler than maybe the liquid that's heated within, it cools and it will condense and it will actually form on the side of the glass. So that's condensation. The last example of phase changes is known as sublimation, and this is one we'll be dealing with in class. This occurs when the surface particles of a solid gain so much energy that they form a gas without being a liquid first. Okay, and vice versa, can go from a gas to a solid as well. Sublimation is found primarily in what we know as dry ice. Okay, and we'll see this in a lab experiment, that what happens is as that the solid, carbon dioxide gas in this case, when it reacts with the ambient temperature in the air or in a liquid substance, it actually sublimates and quickly changes directly from a solid to a gas. And there is no liquid stage that happens between that. Obviously, not all substances do sublimate. There's a reason for that. And we'll talk more about that when we do this lab. But dry ice is probably the most practical example. So that's WSQ11. I told you not too long as we talked about the phases, the phase changes. So melting, freezing, condensation, vaporization, and sublimation. So answer the questions. You've watched the video, write your summary, and I'll see you in class.
Vibram, the science bomb. The science bomb.